Hello, welcome to the Trebuchet Project for Team 12 Dragon Ball. For architecture selection, we decided to go with a hanging counterweight design as opposed to the fixed counterweight. Justification for that was that we had concerns about the movable base associated with the fixed counterweight and the impact that might have on variability. Base system requirements were defined, and from that we were able to develop some system level verification tasks, which are listed in the table here. The base system was decomposed into two macro chunks or subsystems. They're identified as the support structure and then the firing mechanism. The support structure is highlighted, components are highlighted in the table below in green, and firing mechanism in yellow. Of those decomposed components, of that decomposed list, there were 14 components that make up the entire system. Using Minitab simulation, we were able to run a mean effects simulation on the inputs for the scoring formula. That variation was used to help us determine what we needed to try to focus on maximizing from a trade-off standpoint. The outcome of that analysis was that we were going to target greater number of hits, higher weight on our ammo, and greater Dmax. The other terms were considered to be of lower value. Very early on, we realized that maximizing the arm length was really critical to helping with Dmax. So some calculations were done to help figure out what arm length could fit within the base box requirement. With this information, we were able to use a simulation that was provided by virtualtrebuchet.com to determine what sort of distances and like geometries we could go after in our base design. With this information, we were able to we ended up targeting a score of around 150. Dmax, Dmin, H, and other constituent inputs to the score are shown here as well. For key interfaces, we laid out the system into all the base components. In the drawing to the right, you can see the interfaces highlighted with black lines, blue lines, and blue squiggly lines. Black lines are physical interfaces, blue lines are spatial, and squiggly blue lines are key interfaces that were areas that we were specifically worried about failures. We took the base system requirements and cascaded those down to the base components for handoff to the component owners to help them with their designs. When it all was pulled together at the end, we came up with a final system design that is highlighted here. For our reflections on the program, there were two specific things that I think stuck out to us the most. So the DSM, this is a really powerful tool for defining the workflow and structure, and should allow for better project management and scheduling, as you can help identify all the interactions between the subsystems. The Systems V forces you to think about robust handoff from system to component level teams, which we got to see firsthand as part of this project, and gave you a great visual for the overall workflow.